Find the second derivative of sine y equals x to the fourth minus y plus 9. To find the second derivative, we will start with finding the first derivative. We have an implicit equation here, sine y equals to x to the fourth minus y plus 9. It is not solved for y in terms of x, and it's not possible to solve it for y in terms of x, so we will have to find the derivative implicitly. This is done by taking the derivative of both sides with respect to x, indicated by a prime on both sides. On the left side, the derivative of sine is cosine, leave the inside alone, and then multiply by the derivative of the inside. The derivative of y is y prime to complete the chain rule. Every time we take the derivative of a y term, we will have a y prime multiplying it due to the chain rule. On the right side, the derivative of the first term is a power rule. Bring down the power, subtract 1 from it. The derivative of the second term, minus y, will be minus y prime, and the derivative of the third term will be a 0. We have two terms that have y prime in them. The one that's on the right, we can add over to the left to isolate the y prime term. So we will have cosine y, y prime, plus y prime equals to 4x cubed. We can now factor a y prime on the left. And we have cosine y plus 1. And then equals to 4x cubed. And now we can solve for y prime by dividing both sides by what's in the parentheses on the left side. And we will now have our first derivative, y prime, which is 4x cubed over cosine y plus 1. The second derivative is found by taking the derivative of the first derivative. So y double prime will equal the derivative of the right side, which is a quotient, and we'll follow the quotient rule. The derivative of the numerator, which is a power rule, bring down the power, multiply it with the 4, subtract 1 from it, times the denominator left alone, minus the numerator left alone, times the derivative of the denominator. The derivative of cosine y is negative sine y, and then times y prime to complete the chain rule, and the derivative of the 1 is a 0. All of this is over the denominator squared. So we have a 12x squared times cosine y plus 1. The second term we have a double negative, so that will multiply to become a positive. We have a 4x cubed. We have a y prime, and we have a sine y. All this is over the denominator, which we'll leave alone. So there's the second derivative, y double prime, in terms of the first derivative, y prime. Everywhere we see a y prime, we have to replace it. There's a y prime right here, and we have to replace it with this expression for y prime. So our y double prime will equal to 12x squared times cosine of y plus 1 plus 4x cubed times replacing y prime with 4x cubed over cosine of y plus 1, and then times sine y. And then this entire thing is divided by cosine of y plus 1 quantity squared. So we have 12x squared times cosine of y plus 1, leave that first term alone, plus the second term, we have a 4x cubed times a 4x cubed. 4 times 4 is 16. X cubed times x cubed, we add the exponents, x to the 6th. There's a sine y multiplying in the numerator, and in the denominator we have cosine of y plus 1. And then all this is over the cosine of y plus 1 quantity squared. We have a fraction in the numerator, and we need to add the terms together in the numerator by putting them over a common denominator. The denominator of that fraction is cosine of y plus 1, so I need the first term here to also be over that denominator of cosine of y plus 1. So our next step is to get a common denominator between those. So I will have 12x squared times a cosine y plus 1, and we will multiply it by a cosine y plus 1 over a cosine y plus 1, a form of 1, so as to give it a common denominator. The second term we'll leave alone since it already has that common denominator. And then the entire thing is still over the cosine y plus 1 squared. The first term will be 12x squared times a cosine y plus 1 times another cosine y plus 1, which we can write as cosine y plus 1 squared, all over cosine of y plus 1. And the second term, which we can leave alone, as it already has that, common denominator. So y double prime is going to equal, we can add the fractions together in the numerator, now that they have a common denominator. And then the entire thing is over that overall denominator. What we can do is take the denominator fraction, which is not yet a fraction, but we can put it over 1, and now we can reciprocate it and multiply it with the numerator. So we have the numerator expression over its denominator, and we're going to reciprocate the denominator fraction and multiply it, so it'll be 1 over cosine of y plus 1 squared. Now we already have a cosine of y plus 1 here. It's to the first power. In the case of multiplication, we can add those exponents. In the numerator, we're multiplying everything by that 1, which doesn't change at all. So our y double prime second derivative will be (12x squared) times cosine of y plus 1 quantity squared plus 16 x to the 6th sine of y, and the entire thing divided by cosine of y plus 1. We add the exponents 1 plus 2 cubed. It may be tempting to cancel the cosine y plus 1 from the numerator with that in the denominator, but we have to factor it first. In the second term, this does not have a cosine of y plus 1 with it, so it's not possible to factor, and therefore it's not possible to cancel it at all. And we are therefore in the simplified form, and there's our second derivative, y double prime.